Welcome to the CEGE CONNEXT Lunchtime Seminar Series. We launched this quarterly virtual event to showcase world-class research in the Civil, Environmental, and Geodetic Engineering Department, and to do so by having faculty share perspective on how recent innovations are relevant to practitioners. It's an opportunity to reconnect the department to former student members and to highlight that the CEGE department can serve as a resource to you after graduation. It's my pleasure today to introduce Associate Professor Dr. Jeff Bielicki. Dr. Bielicki holds a joint appointment in our department and also the Glenn College of Public Affairs here at Ohio State. He integrates expertise from these two disciplines to examine research questions at the intersection between energy and environmental systems and policy decisions. Specifically, he is focused on questions related to carbon management, renewable energy, and the energy-water nexus. Dr. Bielicki is also the research lead for sustainable energy at the university-wide Sustainability Institute, and he serves as the program director and principal investigator of the OSU Empowerment Program. And this is a traineeship program for PhD students funded by the National Science Foundation, in which graduate students have the opportunity to examine aspects of energy, energy supply, energy policy, and all of the associated issues of environmental impacts and access. I ask today that you please drop questions in the chat function at any time during the presentation, and I will moderate the Q&A session at the end of Dr. Bielicki's presentation. So let me welcome Dr. Bielicki.
Thanks, Allison, and thanks to you and Kevin for asking me to be a part of this. It's nice to see so many people joining. It's been, I think some of your names are familiar. I have been here for 10 years, and I'll start my presentation now. So Allison gave a nice brief little introduction of me and what I focus on, and I'm going to go into some more depth with a focus on a particular project and some context around it that we just are kicking off here at Ohio State. So first of all, who am I? My background is in mechanical engineering, and I worked for several years at the time it was the world's largest atom smasher outside of Chicago, Fermi National Accelerator Laboratory, where I was in charge of designing devices and infrastructure that make antiprotons. Why do you make antiprotons? Well, they don't exist naturally, so we make them so that we can smash them into protons and look at the pieces. I loved that job. It was great. It was extremely interesting. And it really helped sort of set up my perspective about the role of the government and funding research that isn't necessarily have a business model associated. There's no, as of yet, no business model in making antiprotons, but we have a large track record of once we understand things, of finding ways to have that transition into the economy in different ways. I also worked at the University of Rochester Laboratory for Laser Energetics, which was dedicated to laser-induced nuclear fusion. I was in the optical manufacturing department, and so with lasers, you have a lot of optics you got to worry about, and when you're trying to do nuclear fusion with lasers, you have a lot of heat you need to worry about. And so those are my primary tasks, were to help enable laser-induced nuclear fusion research. As many young enterprising engineers do after they graduate, I went on to get an MBA. And focused on economics and strategy and organizational behavior during my MBA. And that damn MBA screwed up my life. Through the exposure to economics and strategy, it diverted my path. And I was on the trajectory. I actually started a PhD in mechanical engineering, but this MBA was, after I left Fermilab, this MBA was rattling around in me too much, and I wanted to figure out a path where I could integrate economics and organizational behavior and strategy and sort of these less technical perspectives with the technical. That led me to get an MPA, Master's of Public Administration, in a program where I could take any course throughout 2 universities that I wanted. So I actually blended public policy and engineering courses, which ultimately led me to get a PhD in public policy. Along the way, I mentioned that I worked at Fermilab. I've worked at 3 different U.S. Department of Energy national labs: Fermilab before graduate school, Los Alamos National Lab during graduate school, and Oak Ridge National Lab after graduate school. I've also got colleagues and IDs at several other national labs: Lawrence Livermore National Lab, Brookhaven National Lab, Idaho National Lab, and Argonne National Lab. And again, these are Department of Energy national labs with the mission orientation to evolve our relationships with energy in all of its ways, shapes, and forms. Now, since 2013, I've been on the faculty here, as Allison said, both in CEGE and the Glenn College of Public Affairs. I'm also affiliated with the Environmental Science Graduate Program. And as Allison mentioned, I serve the university as the research lead for sustainable energy at our Sustainability Institute. I'm also on several advisory committees for the Enterprise for Research, Innovation, and Knowledge around energy and climate change. Serve on 2 visioning committees convened by the provost for education and research around sustainability. And as Allison mentioned, I run our OSU Empowerment Program, which is a PhD training program for any student across the university in any discipline studying any aspect of energy. And I'll speak a little bit more about that towards the end. So I'm going to start big. Before that, my talk will be in 3 acts. First, the context for the work I engage in, this intersection between where energy and environmental systems and policy intersect. Then I'll talk in more detail about this Fleets for All project that we are doing funded by the U.S. Environmental Protection Agency, and then some other large-scale efforts in addressing issues in the interaction between energy and environmental systems and policy, and where I come from in those. So starting big, we are here. If anybody wants to drop into the chat how we got this picture, feel free to do that. We're also here. We have had, and this is the gross domestic product going back about 70, 75 years, 80 years actually, for the United States. We have had an enormous accumulation of wealth here in the United States. And to drive that wealth, we use a lot of energy. This is the primary energy consumption by source for the United States, again, going back about 80 years. And you can see that we are using the total amount of energy we've used since about 2010 or so has sort of plateaued around 95 quadrillion BTU. For those of you that do stuff with energy, we have all sorts of fun units, of which petroleum and natural gas and coal, the fossil fuels, make up the dominant share. They still make up the dominant share of our use of energy. So collectively, these fossil fuels still provide about 75% of our primary energy. And you can see some evolutions here. Beginning around 2008 or so, natural gas started to take off, whereas coal started to decline. And that's due to some fundamental shifts in our energy system. You'll also see that renewable energy, and this encompasses wind and solar and hydroelectric, has had a steady increase, but has actually started to accelerate a fair amount, in part in correlation with the natural gas here. Now, what happened? This is a consequence of hydraulic fracturing that has enabled us to produce natural gas and oil from these tight shale seams. The natural gas and oil has been there for millions of years. It's just beginning in the late 2000s, we were able to more economically extract it. And I'll talk a little bit about that later. So again, we are here, about 95 quadrillion BTUs. Now, as you might expect with this reliance on fossil fuels, we also emit a lot of carbon dioxide. This graph here in the top is, again, the energy demand or primary energy consumption we have here in the United States, again, about 95 quadrillion BTUs. And here are the associated carbon dioxide emissions. And you can see that we were increasing until about, roughly late 2000s, and then it started to taper off. And a major reason for that is on this prior slide, the acceleration of coal and the acceleration of natural gas and the decline of coal. And the reason is that natural gas per unit of energy has about half as much carbon dioxide emissions as coal when it's used for electricity. So the carbon content of coal per unit of energy is higher than the carbon content of natural gas. And so this shift away from coal towards natural gas has started to bend over our CO2 emissions from energy here in the United States. Now, back in 1896, 7 years before he won the Nobel Prize for chemistry, a gentleman named Svante Arrhenius wrote an article entitled "On the Influence of Carbonic Acid Upon the Temperature of the Ground." Now, what is carbonic acid? That's carbon dioxide with a little water vapor in it. That is carbon dioxide in the air. And in this article, he quantified the contribution of carbon dioxide to the greenhouse effect and speculated about whether variations in the atmospheric concentration of CO2 may contribute to long-term variations in climate. Now, this 1896, the end of the 1800s, was just after the Industrial Revolution had kicked off and became a major force and a major driver of a lot of industrial activity. And we were primarily relying on coal to power that, the Industrial Revolution. And he basically said, well, if we're combusting all this coal and producing a lot of carbon dioxide as a byproduct, what happens there? And so, it goes in the atmosphere, and he published this study on the potential implications of CO2 in the atmosphere on climate. Now, for a while, he was considered to be the first person to identify this connection between carbon dioxide in the air. Again, this is about 130 years ago. But more recently, it was discovered that 35 years before that, John Tyndall, who was no intellectual slouch himself, is fellow of the Royal Society, gave a lecture on the heat absorption of gases. So in 1861, now we're going back about 170 or 160 years ago. He identified that different gases absorb and radiate heat differently, including having studied carbon dioxide. So when this lecture was discovered, then the consensus was that, John Tyndall was maybe the first to identify the connection between carbon dioxide and its heat absorption characteristics. And then it turns out that 5 years before that, another talk was given, a different talk was given at a conference. You can see here it was entitled "On the Heat in the Sun's Rays." And this talk was based on this really short paper. This is the extent of it. And in this talk, what the author did is put three glass spheres in a greenhouse and filled them with different gases, one of which was water vapor, water vapor, another of which was carbon dioxide, carbonic acid. And in the conclusion that this paper had is that the highest effect of the sun's rays was found to be in carbonic acid gas. And an atmosphere of that gas would give to our Earth a high temperature, and if the air had mixed with it in a larger proportion than at present, an increased temperature must have necessarily resulted. So 5 years before John Tyndall, this paper was published, and it was sort of lost to history for a long time. And why was it lost to history? Well, partly because it was a woman who did this work. She was not allowed to present at this conference. A man had to present on her behalf. So More recently, we've discovered that Eunice Foote, an amateur scientist, was actually the first person to make the connection between carbon dioxide and its heat trapping capabilities. Now, she was also a women's rights pioneer. She signed the Declaration of Sentiments and the Seneca Falls Women's Rights Convention. You can see her down here. And as I mentioned, there's been a more recent understanding. You can see this paper published only 3 years ago that talks about about how Eunice Foote predated John Tyndall, and asks the question of who did John Tyndall actually know about her work and not give her credit. The consensus opinion is that no, they were on different sides of the ocean, and at that point, information didn't travel as quickly or as easily as it does now. But the point is that we need to we are in reconciling a lot of past records. We need to have a better emphasis on the contributions of people who have not necessarily been given the notoriety that they should have. And so, with that backdrop, here's another historical record. This is the amount of carbon dioxide in the air since the late 50s from the Mauna Loa Observatory. And if you go back to about 2,000 years, data from the Aladome Ice Core, you can see that there's a great acceleration during the industrial revolution of the amount of carbon dioxide in the air. So the orange is from the ice core. It actually goes up to around here, and the data from Mauna Loa is overlaid on it. That's the red there. Now, throughout the course of history, the history of the Earth, there's always been variations in the amount of carbon dioxide in the atmosphere. This is from a collection of ice cores that goes back 800,000 years. So there's always been this natural variability. And we know that the natural variability of carbon dioxide in the atmosphere is correlated with the temperature of the Earth. You can very clearly see the correlation of carbon dioxide with temperature there. And so if we look at this historical record, the problem is we've pushed our climate so far out, the amount of carbon dioxide in the atmosphere so far out of the natural oscillation that we are really starting to see some effects of this carbon dioxide in this overaccumulation of carbon dioxide in the atmosphere. One of the things that's happening is temperatures are getting hotter. This is a plot from NASA on the monthly temperatures. So in the northern hemisphere. So as you would expect, in the summer it's warmer, in the winter it's colder. But this is a plot of the average monthly temperature for each year since 1880, and each year, each decade, or each 20 years is colored differently. So long time ago, the 1880s to the 900s are these blue, and then the middle of last century, the 1940s and 60s is green and yellow, and then we get into orange in the 80s, and so and red in the 2000s, and as of September of this year, which is actually the hottest year on record, our temperature has even exceeded that. So what you can see here is that over time, over the last 150 years, 140 years, the average temperature over the course of the year has gradually marched upward. And in fact, the Earth is hotter now than it was even only a few decades ago. So, as a result, every few years, about 5 or so years, the Intergovernmental Panel on Climate Change releases a report. Now, the first report was in the early 90s, and again, every 5 or so years, they release another report. Now, these reports are put together by thousands of scientists who have to agree, and it's not necessarily in individual scientists' incentives to agree with others. In fact, we are as academics, we are actually if we prove that other people what existing understanding is wrong or that it needs to be revised, that's actually in our incentive. But with these IPCC reports, again, there's hundreds to thousands of scientists involved with each one, and they have to agree, and the report has to be approved by the governments involved. And so by definition, this is a consensus report, and given all of the agreement seeking, it is by definition conservative. And by the time it's published, it takes several years. It's already kind of out of date. But the most recent one, a couple of years ago, stated, it is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, rainfall, and droughts more frequent and severe. Recent changes in the climate are widespread, rapid, and intensifying and unprecedented in thousands of years. Climate change is already affecting every region on Earth in multiple ways. The changes we experience will increase with further warming. Unless we do a lot, do it quickly, and do it now, to reduce greenhouse gas emissions, we will not be able to limit warming to 1.5 degrees Celsius. That's above that pre-industrial temperature. Now, we here in the United States tend to speak in Fahrenheit. So there's 1.8 degrees Fahrenheit per degree Celsius. So we're talking upwards of almost 3 degrees Fahrenheit on average, warmer than it was only 150 years ago. There are some changes to the climate system that we cannot undo, but we could slow and maybe even stop some others if we make these large-scale rapid changes. And overall, the point is that if we go back to that graph of primary energy consumption, about 75% of the ways in which we use energy for our economy is wrecking the environment upon which our economy and our well-being depend. We evolved in a certain climatic envelope, and we are adapted to that climatic envelope, and our activities are pushing the boundaries of that envelope in which we live, and really causing some major challenges. Now, talking about historical records, we need to reverse course on more than just greenhouse gases. Another huge tome of the IPCC report is that states unequivocally climate change is a threat to human well-being and the health of the planet. And this key finding underlies the urgency for climate action, focusing on equity and justice. On one hand, the climate change that we are experiencing is due to the greenhouse gas accumulation in the atmosphere, and the responsibility for those gases is uneven across the planet. As well, in addition, as we want to change how we do things, people in communities will benefit, have a different ability to benefit or be a part of the transitions we're seeking. So not only are some aspects of the world unevenly responsible, other aspects of the world are unevenly impacted by climate change. And as we try to overhaul how we do things, we need to consider everybody and not just those who have been benefited in the past. So that brings me to this Fleets for All project, the recent EPA award that we got. It's facilitating local electrified energy and transportation services for all. Now, there are, as I mentioned, primary challenges of our time is to overhaul our infrastructure, and I've been talking mostly about energy, to address and correct its consequences. Now, right now, transportation is responsible for about 28% of our greenhouse gas emissions, and commercial and residential places where we buy things and live are responsible for another half as much. So collectively, a little bit more than 40% of our greenhouse gas emissions in the United States are due to these sectors. Now, historically, underserved and marginalized communities have unequal ability to benefit from changes. So I have an electric vehicle and I have a garage, and I'm in the position to wire up my garage and increase the electrical service to it so I can charge my electric vehicle in my garage. Many people do not have that luxury, and they've been marginalized by a number of consistent things: discriminatory citing of polluting infrastructure. They tend to have more exposure to pollutants. So again, if I'm driving in my car along the road, I have my own vehicle. I'm not standing on the side of the road waiting for a bus to pick me up and breathing in all the diesel exhaust and other exhaust from internal combustion vehicles. So marginalized communities tend to have more exposure to pollutants. They also, as a result, tend to have more adverse health outcomes. They're more vulnerability to disruptions. So when we have a power outage, for example, I have more ability to go somewhere else, and if it's during the summer, cool myself off. I have more mobility. I also these communities also tend to be turned back on later, so they have less ability to compensate for the disruption, and are also less likely to be turned on as quickly as others. And there's a host of other socioeconomic challenges associated with them. And as a result of acknowledging and admitting this, the day that President Biden took office, he issued an executive order on advancing racial equity and support for underserved communities through the federal government. And so this important consideration of all people and leveling up the experiences and opportunities for all people underlies a number of activities that are going forward, both from the federal level and in universities. Now, as I mentioned, the ability to participate in energy transition is unequal. All else equal, a transition towards electrified vehicles is great because you are moving from tailpipe emissions, these dispersed, diffuse emissions that are mobile, to using electricity to power those vehicles. And what matters then is where the electricity is coming from. If it's coming from wind and solar with no operational emissions, that is great. If it's still coming from a coal or natural gas fired power plant, then you're having large point sources where it's a lot easier to add SO2 scrubbers and particulate controls and mercury controls to address the emissions in a large point source. And it's very hard to do it on a lot of millions of mobile and diffuse sources like cars. But the ability to participate in a transition in this context to electric vehicles is unequal. This is a recent map of the supply of electric vehicle chargers. You can see that the circles indicate the size of the circle indicates the amount of electric vehicle chargers. The color of the county indicates the average income in that county. And you can see a variety of important correlations here. First, that the electric vehicle charging infrastructure tends to be located in these purpler areas, and these are the richer counties. You don't see much in the redder counties, the lower income, on average lower income counties. Now, this is a map of Chicago. So income has been a driver of EV charging infrastructure. This is a map of Chicago, a recent article in the Washington Post that shows where the electric vehicle chargers are located. Those are the dots. And the census tracts are colored by race. So you can see for those, I used to live in Chicago. For those of you that are familiar with Chicago, you may know that this is, the north side of Chicago tends to be populated by white people. The south side down here tends to be populated by Black people, and Hispanic is the yellow. But what you can see again is that the publicly available charging stations tend to be up in Wrigleyville, Lincoln Park, Wicker Park, and so on, very much correlated with race. And in fact, right now, about 95, 96% of public electric vehicle chargers are in predominantly white counties. Only 4 to 5% are in predominantly Black or African American counties. So clearly there is an unequal distribution of infrastructure to support a transition, in this case, to electric vehicles. Now, also, it's not just about how we move, it's also about what we do in our houses. We have furnaces, water heaters, stoves, and so on, tend to run on natural gas. Furnaces and water heaters vent when you're burning the natural gas. Furnaces and water heaters vent the byproducts of that combustion outside, but stoves are mostly unvented, right? It's a cooktop, right? You're burning the natural gas right in your kitchen, and often eating really close, sitting down for dinner really close by. Now, natural gas, when you burn it, you emit carbon dioxide, but there's also a lot of methane emitted. Now, when you turn on the stove, you hear that little tick, 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 tick. That's a little piezoelectric valves creating a little spark until it ignites the natural gas, combusts it, and releases carbon dioxide. So, but while it's trying to light that gas, it's emitting methane. And in fact, there's also leaks throughout our houses and the infrastructure, the natural gas infrastructure, the distribution and transportation infrastructure that result in methane leaks just from stoves that are comparable to about 500,000 passenger vehicles. This is based on work that was recently published. So methane is actually, from a climate standpoint, it has a higher radiative forcing per unit per molecule than carbon dioxide. It's the worst greenhouse gas in the atmosphere, and we emit a lot of it, and we rely on a lot of it for our internal our activities within the house. Now, there was a recent article that says, the climate fight will be won in the appliance aisle, and really what this is about how we not only need to transition to electrified mobility, we need to transition to electrified home appliances, stoves and water heaters and stuff, and so on. And part of what this article points out is that the incentives for these transition are unequally available to people. One of the characteristics of the Inflation Reduction Act and the Biden infrastructure law is that there's a lot of tax incentives in there for electric vehicles and so on. And that is great. And that is really helpful in pulling through new ways, new technologies and new ways of doing things. But it's contingent on having a tax burden. And for low-income people and marginalized people who have much less or maybe even no tax burden, then they can't benefit from these incentives. So in addition to carbon dioxide, the combustion of natural gas also emits carbon monoxide, formaldehyde, nitrogen dioxide. Nitrogen dioxide is toxic even at low concentrations, and it can trigger breathing problems for people like me who have asthma or other chronic obstructive pulmonary diseases. And in fact, it's been shown that kids in homes that have gas stoves have about a 20% increased risk of developing respiratory illnesses. In homes with poor ventilation, small kitchens, or without the use of range hood, read underserved. Using the cooktop or oven can cause concentrations of NO2 indoor concentrations to surpass the guidelines for 1 hour exposure outside of it. So we're burning this in our houses right near where our kids are eating and playing and so on. And to the extent that the result is that the indoor concentrations of nitrogen dioxide exceeds the outdoor limits. And there's actually currently there are no indoor air quality standards for nitrogen dioxide. So again, we have to really, if we value health, we need to do what we can to transition away from natural gas stoves. Now, about a year and a half ago now, actually it was more than that now, a team of us from Ohio State across 5 colleges, engineering, public health, the Glenn College, food, agriculture, and environmental sciences, and arts and sciences came to get together and pitched this project to the EPA called Fleets for All. It's a community-engaged effort to bend trajectories around electrified energy, appliances, and mobility in ways that improve the conditions for 15 underserved focal communities in the Columbus metropolitan area. I'll point out that so this project, again, there are 6 of us and 6 faculty and a postdoc involved. 4 of us are affiliated with CEGE. That's me there on the left, wearing the red glasses. I'm only partially covered because I have a joint appointment, and Daniel Gingrich down at the bottom there, who will be speaking in a few months in this CONNEXT series, he's partially appointed in a different engineering department as well. So for this project, we have 4 partners. 3 of them are in the Columbus metropolitan area. We have the Electrification Coalition, that is a national nonprofit dedicated to helping to electrify appliances and mobility. For those of you who have forgotten, may have moved on and may have forgotten where Ohio is, and let alone where the Columbus metropolitan area is, here it is. I gave this talk at another conference, and I just felt I gave a version of this talk at a different conference, national conference, and I had to point out that where Ohio was to some people, so I kept it in there. We also have the Mid-Ohio Regional Planning Commission. They have jurisdiction over 15 counties in central Ohio. We have the Franklin County Public Health, which is by definition responsible for Franklin County and the neighborhoods in it. But it does not have jurisdiction for Columbus, but we also have the City of Columbus and Sustainable Columbus involved as well. Now, I mentioned that this is about working with these 15 underserved communities. Now, these 15 underserved communities in the Columbus metropolitan area exhibit all the hallmark effects of being underserved and marginalized. For example, relative to Franklin County as a whole, they have higher rates of asthma, lower life expectancy, higher rates of infant mortality, higher rates of lower birth weights, much more incarceration, much more violent crime, many more lack a high school diploma or GED, and the unemployment rate is higher, again, than Franklin County as a whole. They also have a much higher vacancy rate. So these areas in Columbus have been historically set aside. You can see in the data, in the conditions and their health outcomes that they're not served as well as other parts of the county. So what our first objective with Fleets for All is to partner with these communities to understand their needs for electrified energy and mobility. It does not work well when us academics come in and try to tell people what they should do and how they should do it. We need to really work with the communities and listen to them. And part of this effort is to do that. We're also going to be working on evaluating how different policies that are on the books, as well as ones that could be proposed, may be more or less effective in increasing the electrification of appliances and mobility to meet these needs that the communities have. Now, for some examples are the EV Readiness Ordinance, if you remember, if you're from around here, 2020 passed a Renewable Energy Aggregation Program. There's several efforts underway in the city and the county to encourage electrified mobility and home appliances. So there's a number of effort gaps with these existing efforts. I won't go through them in detail, but part of what we're doing is plugging, while working with the communities, we're seeking to plug these holes in between these efforts, as well as understand how well those efforts are, how effective they are. We're also working on developing transmission and investment strategies so we improve health and environmental and social conditions. If you think about it, if we have many more electric stoves and electric vehicles, you're going to have, as one example, more electricity demand. So how do we build out the regional energy system to provide that additional energy that's now being demanded, and how we do that in ways that reduce emissions and improve health and environmental outcomes while serving the needs of the people. Our third objective is to understand how residents of these underserved and marginalized communities make decisions. Basically, how their identities and group affiliations inform the decisions they make. We have this Venn diagram of three ecosystems that influence what people decide to do: the information ecosystem, the conditions or constraints ecosystems, and the value and identity ecosystem. Now, within these overlaps, you can see budget is a combination of constraints and information, perceptions is information and value and identities, and socioeconomic conditions are conditions and overlapping conditions and value and and identity. So, for example, again, with perceptions, like what I know and have been exposed to intersects with the identities that I have. So I may be a very religious person, for example, and I would then be exposed to certain types of information that influences my perceptions of things. And so within this value and identity ecosystem, part of our work with the communities is to understand these nested influences on their decisions: the behavioral context, the socioeconomic context, the community, an organizational context in which they live, their jobs. I'm in higher education, so I have this organizational culture that I'm marinated in every day. I also live in a certain part of Columbus that is a community. Many people have religious communities, sports communities, and so on. There's also the broader governmental and institutional influences on our values and identities, and again, the overall cultural influences. Part of being an American means certain things to many people, as an example. So within this overlapping Venn diagram is where the individual and household decision making occurs. And so again, we're working to understand what are the drivers of this decision making and how we can influence influence that decision making so that it helps to improve conditions for everybody. Our third objective also has, like I said, the informational interventions to inform these decisions, largely around public health risks and the consequences. So I've been building up this causal loop diagram. This is a simplified version of the project. And overall, we have a number of hypotheses. I won't go through them, but Fleets for All is a community engaged effort. It is a community engaged research effort that has many of the elements of effective community engaged research in it. We're working with the communities. It's centered on the communities. It's not us in the ivory tower saying, withdrawn, saying this is what our objective analysis says that you should do. It's about changing conditions and informing investments and policies, building capacity in the communities, sharing the leadership for that with the communities. If you remember, we have a diverse team, and sometimes, unfortunately, scholarship around community engaged research is not valued as much as other scholarship. We are working to change that. We're giving resources to the communities. We'll be sharing data, and again, by working with the communities and having various people from the communities as well as translators involved in the project, culturally specific communication and dissemination, as well as culturally specific assessments. So again, Fleets for All, this project is seeking to bend trajectories around electrified mobility and home appliances. We're seeking to understand the barriers to the adoption and improve outcomes for those at the margins. Now, there's a lot of opportunity to build this out. We are working to partner with others. We're working in the communities. We might as well, if we're having focus groups and surveys and interviews and so on, we might as well ask about their relationship with food and their food deserts and food security and so on. The effect of urban heat islands and greening infrastructure and resilience and so on are other ways of working to build this out. So that's a description of our Fleets for All project. And I'll end in the third act. I'll end with this is one of several large multidisciplinary and transdisciplinary projects I have been a part of, all around primary challenges for trying to stabilize the climate. We clearly need to reduce the emissions of greenhouse gases to the atmosphere. Part of that is by deploying more renewable energy technologies, but deploying them is not sufficient. We also need to be able to rely on them more. So wind and solar only work when the wind blows and the sun shines, and they have pretty low capacity factors as a result. But if we can figure out ways to have more efficient wind turbines that can extract energy from less windy wind, and have PVs that are more efficient at extracting energy from the sunlight that they get. Today in Columbus, we actually have sunlight. It's not often the case, if I'm sure you remember. And so we need to be able to rely on these renewable energy technologies more. And part of another challenge, though, is that the combination of these help us bend over trajectories. This is the trajectory we are on if we need to be on if we want to have a chance of stabilizing a 66% chance of stabilizing the climate at 2 degrees Celsius above pre-industrial temperatures by 2100. But you'll see down here that requires that we start removing CO2 and other greenhouse gases from the atmosphere. So it's not just about stopping to emit it or in relying on other things that don't emit it. It's also about removing the carbon dioxide and other greenhouse gases from the atmosphere. And there's a variety of approaches that can do this. But this is a fundamental challenge with our energy system and the way we do things that we need to be able to navigate in ways that are still providing the energy for our economy upon which we depend. And so, as I mentioned, I've been involved with several large projects and proposals. About a decade ago, I got almost $2 million from the National Science Foundation for using carbon dioxide to produce geothermal heat. Almost $10 million for investigating shale development, $2.4 million for a food, energy, water systems grant, $3 million for this empowerment program that Allison mentioned, plus other proposals all around various issues where energy and environmental systems and policy intersect. So briefly, the U.S. is not at a loss for resources. We have a lot of wind. We have a lot of sunlight, not so much in Ohio, and we have a lot of geothermal heat. We also have a lot of deep aquifers. These are more than a kilometer below ground where we can put carbon dioxide. We can leverage the experience from the oil and gas industry that's used to pulling fluids like oil and gas out of these aquifers. We can use those aquifers to put the carbon back in and store carbon dioxide before it gets emitted to the atmosphere. And some of this work has been looking at how you can use geologically stored CO2 to produce geothermal heat and electricity. Now, there are a number of opportunities. These aquifers exist under about 70% of the country and about 80% of the world. Turns out that if you use carbon dioxide instead of brine, which is how we typically do, we produce geothermal heat, carbon dioxide has better heat mining characteristics. Geothermal energy is dispatchable, meaning we can turn it on and off when we want. We are not subject to fluctuations in wind and solar. And we need geologic CO2 storage in order to bend over the trajectories to save ourselves from the climate change. But there's a lot of challenges. There's not as much awareness about geothermal energy. Geothermal heat has a low energy density, so you need a lot of well-functioning wells. Those are hard to locate because the subsurface, we can see where the wind blows and the sun shines, but you can't necessarily see what's underneath the subsurface. And it's a challenging social environment for CO2 storage. Part of that is a NUMBY phenomenon, not under my backyard. Personally, I've published a dozen papers and plenty of conference papers on these issues, including one that is now just published with my postdoc that looks at how to use carbon dioxide that you put underground to produce geothermal heat to drive direct air capture, CO2 capture, these technologies that extract carbon dioxide from the air. This is a negative emissions technology. So again, several large projects. There's a number of characteristics of these. I mentioned this almost $10 million project I was a part of. The goal was to establish a field site for shale development in the Utica or Marcellus Shale and understand the environmental and social consequences of these hydraulic fracturing operations. If you remember, I mentioned back at the beginning of my talk how there's been this acceleration of natural gas production and this decrease in coal. Shale development is primarily responsible for this, in part by making natural gas plentiful and cheap. And so it has displaced coal in electricity generating infrastructure. Now, a lot of people will assume that, well, we figured out hydraulic fracturing or directional drilling with all the telemetry and all the stuff that we need to be able to extract the natural gas and oil from these tight shale seams, that we figured that out about 15, 20 years ago. That's not the case. Actually, we had these technologies and approaches for decades. The real change was in 2005. The 2005 Energy Policy Act exempted hydraulic fracturing from regulation under the Safe Drinking Water Act. This is what unleashed hydraulic fracturing activities. That's not to say that we haven't learned a lot and developed more technologies since then, but removing a regulation has really been what's been helped propel natural gas development. I mentioned this other food, energy, water systems grant, which is how, which the overarching question was, how will retreat from global engagement? We wrote this grant during the 2016 presidential election cycle when there was a lot of talk about tariffs and so on. How, if we remove ourselves from trade, we deglobalize, will affect energy water systems in the 5 states of the U.S. Great Lakes region. Now, this region has a lot of agriculture, has a lot of historical energy production, fossil fuel production. The Great Lakes themselves provide 20% or account for 20% of the world's fresh water. The region, these 5 states have about 15% of the US population and about 13% of its GDP. It's an important region for the country and the world, but we also have a number of impacts, such as harmful algal blooms developing in Lake Erie due to nutrient runoff from our agriculture. So this project involved a whole bunch of models and interviews and so on. This is a brief, simplified version of the project. I particularly worked on scenarios that informed all of them. Now, the last research effort I will briefly touch on is emerging work that I'm working on what's called agrivoltaics. And basically, this is about co-locating solar photovoltaics with agricultural activities. So in order to stop and reverse the flow of carbon dioxide in the atmosphere, solar photovoltaics are an important component of the portfolio of what we need to deploy. But solar energy is low energy density, and so we need a large amount of area to have solar photovoltaics at meaningful scale. Agricultural lands provide a large opportunity for this solar PV. They also tend to be relatively flat. And we have, as you're aware, a lot of agriculture going on here in the United States. And when you co-locate solar PV with agriculture, there are mutual benefits. First of all, if you have solar photovoltaic arrays, you need to manage the vegetation underneath them. Otherwise, the weeds will grow up and they'll interfere with the wires and everything and block the sunlight reaching the panels. So why not have sheep grazing beneath them? Let the sheep do the vegetation management for you. The sheep also like it because they get some shade. It also provides a advantageous microclimate underneath the PV panels that helps to retain soil moisture, and that retention of soil moisture and the blocking of the evapotranspiration helps to cool the PV panel. So the PV operates more efficiently while the agriculture also operates more efficiently and includes the higher quality biomass production. And so there's a number of efforts going forward looking at how you can either do grazing or crops under or within PV panels. Now, some challenges are that you need to consider the agricultural equipment. and the operations. It changes what the rural aesthetic is. It changes the landscape. So you go from having a primarily green landscape to a primarily black, gray, silverish landscape. And understandably, people might not like that. And there's also perceptions that the land can only be used for one purpose. And there's a challenging political climate for solar PV development due to a variety of contexts. Finally, I'll end with this PhD training program, this $3 million program that I run. This is, in essence, trying to develop the next generation of graduates of the graduate programs to address energy in all of its ways, shapes, and forms. It's a wicked problem which describes a wide range of social and cultural issues that are difficult or even impossible to solve. And there's a lot of characteristics of wicked problems. Everyone is unique, they're multi-causal, multi-scalar, and interconnected. And I hope that through the course of my talk, you've been able to see a lot of environmental, a lot of social, a lot of physical, a lot of engineering interactions and challenges. So the OSU Empowerment Program is a convergent graduate training for a sustainable energy future. It seeks to prepare scientists and engineers to go out of here and be able to address these problems from many disciplines. Now, part of the program has research being done on the program. We have our colleagues in educational studies who are doing research on the program. And a recent article that they wrote is that people in this program have found it to be transformative, and that exposure to other perspectives really help them reconsider their position on a number of ideas. In fact, it's well known that interdisciplinary training exposes students to many diverse perspectives, and previous studies suggest that it develops more innovation capacity and more powerful cognitive development. So what the OSU Empowerment Program is, and a lot of the work I've been doing, is about going deep in some area, but also providing breadth of exposure so that we have engineers bumping up against anthropologists and lawyers and business folks, so that each person is enriched by the exposure to a perspective that they might not have otherwise gained just from sticking within their discipline. I have spoken for a long time. This is me. I'm happy to answer any questions in the remaining time that we have. Thank you for your attention. And again, I'm happy to answer any questions.
All right. Thank you, Jeff. Yes, we do have a couple of questions that came to me in the chat. So the first is the co-locating work that you're we're talking about in combination to the ag department's work on developing equipment that's modified for growing crops between the rows. And this ag project is something that's called the Between the Rows project.
I'm not actually familiar with that Between the Rows project. What I do know, though, is that there is a lot of effort to, corn harvesters, for example, are huge, right? And so you have to have a fundamentally different infrastructure for solar PV if you want to grow corn underneath it or around it. And so there is a lot of effort, I know, to adapt the machinery to the PV context. One of the issues there is, though, that's taking the PV context as given and adapting the agriculture. It actually works better when you take both contexts and adapt them to each other. You have more beneficial synergies.
Okay. And a second question, how is the fleets team ensuring representative underserved community participation in the public input for the grant?
Yeah, so what we're doing is we have several partners, City of Columbus and Franklin County Public Health and Mid-Ohio Regional Planning Commission being the three major partners who have existing efforts with these communities. We've also have on our board Impact Community Action, which works in these communities. And we have the OSU, there's an OSU outreach center I can't remember exactly which community it's in, but it is in these communities. And part of what we're doing is we're not going to be sitting in our offices doing this work. We are going to those communities, having interviews and focus groups in their communities, so that we are not relying on them to transport themselves. We are transporting us to the communities to talk with them and to interview them and have focus groups, which will then inform a number of things, including a survey that will be more widely distributed. So we have a number of partners as well as people on the team. Daryl Hood, in the College of Public Health, routinely, he's actually the community engaged scholar, a distinction OSU has endowed upon him, for his work with these communities. So he's on the team. We have facilities in the communities that we'll be leveraging.
All right, thank you, Jeff. Our time is come to a close here today, and I would like to thank everybody for joining us today, and especially thank Jeff for his time to share a really broad array of various ways that he's bringing his expertise to inform important questions about energy. I will note that you will receive the CPD credit certificate if you requested one in about 2 weeks' time from the department. So thank you again, and look forward to seeing you at our next event that will be in the new year.